What we're trying to do in this lesson is find the unknown lengths of similar figures. So they're telling us we've got two triangles. The first triangle is smaller. It's angle DEC. And the second one is larger, and that's the entire triangle, and that goes A, B, and C, and back. So what they're saying is those two triangles are similar, and where that leaves us now is we can compare lengths to find a ratio just like we did yesterday. So the first length we're going to be given is DE for that segment. So DE equals 15. And now they're saying that because those are the first two letters of triangle DEC, those are similar to the first two letters of triangle ABC, which is AB, and that length right there for AB is 20. So just as we did yesterday, we're going to reduce that fraction, and we're going to find out that the ratio from the small to the big triangle is 3 to 4. Now, if you look at the bottom leg of this triangle, there's a variable here. There's a distance from B to E that we don't know, and that's what we're going to try to find out today. So we're given that this length here from E to C is 36, and if you look up here, we're going E to C. That length, E to C, is 36, and we don't know B to C, and that's this distance. We do know part of it. We know that this is 36, and this is X, so this whole length is 36 plus X, and that will give us the length from B to C. And now we're going to use the information we received from when we did the DE to AB ratio. We know that that ratio is 3/4 for these similar triangles. So now we're going to put that equal to 36 over 36 plus X. Now, just like you did in last night's homework, you have to do the distributive property. So we're going to multiply 3 times 36 plus X, and that's going to be equal to 4 times 36. Now, if we use the distributive property, we're going to get 108 plus 3x equals 144. If we subtract 108 from both sides, we're going to wind up at 36 equals 3x, and we're going to find out that x equals 12. And if this x equals 12, that means that our line segment from B to C equals 48. And if we can go back and double check to keep our ratio, we know that this was 3 to 4 for the two similar scale factors. And now if we put 36 in here from our first segment for EC, we know that, look at 48 definitely checks out as being proportional. The other way we can use similar figures to find an unknown side length is if we look at a classic example of trying to find the height of a tree. We're going to use things that we do know to find that height of that tree. So if you notice, we've called the height of the tree X. And here's a couple things. We know the angle coming down from the sun is going to be the same for the man and the tree. So the shadow lengths are going to be proportional. So what we can do is set up a ratio that states if we have x over 80, which is the height of the tree and the shadow of the tree, we can say that's proportional to the height of the man, which is 74 inches, over the length of the man's shadow, which is 26. Now all we have to do in this example is cross multiply and solve for x. So if we multiply both sides by 80, we're going to wind up with x equals 5920 divided by 26. And if we go ahead and divide that out, we're going to find out that x equals 228 inches. And if we were actually to go ahead and divide that out by 12 inches, we're going to find out that x, the height of the tree, is about 19 feet. Okay, you're going to try a couple examples of this on your own.